Well, thank you very much for inviting me to speak at this conference, at this seminar. I proposed a topic which is somewhat maybe of a more practical nature than what we have seen so far, but those are some of the reflections, maybe some considerations which come up to mind as one starts talking about, as one studies physics, and then there's some analogies that maybe could be applied, mostly from the methodological point of view, into the study of theology. So I'll be trying to use this talk to show that maybe some methods of physics could be helpful for theology to expand and to improve its method. I don't know, from the point of view of a physicist, this is something which is natural, and I hope that this will show you how a physicist can respond to some of the theological problems, at least what could be a perspective of a physicist on some of the problems of theology. So I chose basically two areas of modern physics, which is quantum mechanics and black hole spacetime geometry, to show that some of the methods, some of the ways in which science proceeds in these two particular important theories of modern physics could give us some hints as to how one could proceed in theology. Short outline of my talk. First I'll make some introductory remarks, mostly on the role of the future of the world in theological explanation. This is something which is very well known. Then I didn't mention it here, I will move over to a short consideration of St. Thomas Aquinas on the eternity of the universe, and then I'll be basically focusing on quantum mechanics as understood by Bohr and Heisenberg, who were the founders of the theory. And then I will move over to black hole space-time geometry, which I think could be in some ways helpful in telling us how to define whether something could be a dogma or not. I hope that the notion of a dogma is pretty much known to everyone. I'm not going to be getting into specifics. What a dogma means is just a truth of faith which has to be accepted and given by some authority, but that's not our concern for the moment. As far as the introductory remarks, I'll make the first one, which is, I think, quite substantial, is that from the times of St. Thomas Aquinas, and probably earlier, it was right to notice that every theology uses a philosophy in order to provide a conceptual basis. What it means that St. Thomas expressed this as that philosophy is the maiden of theology. It means philosophy is in service of theology because it provides a means of understanding what we talk about. And I will stick to another, I think, important statement here, which was very much promoted by Father Bocheński, saying that there isn't any kind of a divine semantics. Every revealed truth that we accept uses for its explanation the same conceptual content as for any other statement. So we don't have in our head, we don't have two kinds of semantics. We have just one set of means by which we understand things. And another remark worth to be made is that theology has every right to be a science, that is, an organized body of knowledge. And as you all well realize, in medieval times, theology was the queen of sciences because it dealt with the highest truth. So it must have retain its character as an organized body of knowledge. I wouldn't want to think anything else about theology. And theological truths are derived from revelations by means of a rational inquiry and with the rules of logic observed, which means that, and this is pretty much what we heard before, that in order to have proper inferences in theology, we must apply the rules of logic, and that is a natural place for logic in theology. Another thing is, why altogether would a theologian want to listen to a physicist? That's the main question. As I specified before, both disciplines require conceptual basis to demonstrate their claims. I mean, we cannot proceed in theology by means of some illumination. We need to have tools to demonstrate what we want to say. Again, the stress goes on logic. Both disciplines, both physics and, for example, and theology, need precise rules how they should justify their inferences. So again, this is the stress on logic. Physics in some ways is contemporarily considered as an exemplary discipline where methodology is most precisely defined and is most rigorous. So in these terms, if especially theology is a divine science, there is no reason why theology should not benefit from this. And I would like to now move over to some examples which will be showing us quite nice situations in which we see how certain theological thinking sits or is based upon our pictures of the world. And I would like to make one note of revelation, which is sort of maybe a bit of a personal attribute to this. We always say that theology deals with revelation, and we imagine as revelation as statements that are sort of given to us from outside, not necessarily from above. Let's leave that out for a moment. And I would say in some ways, methodology could be really, from the methodological point of view, it could be really irrelevant where a statement comes from. We say that, for example, we know a statement from above, which is revealed to us by God, the Trinitarian doctrine. That's something that is revealed to us. We cannot know this from purely rational inquiry. And for example, we can also have a nature make some kind of a revelation to us. For example, when we make an experiment on atomic phenomena, and we observe that there is a manifest discontinuity at a quantum level. Another mystery revealed. And nature speaks to us, and here God speaks to us, and in a sense we get a sentence, we get a statement, which is sort of some kind of revealed truth. It comes to us from outside. And in both cases, we need a fitting conceptual basis in order to generate our explanations. We know that there is a big explanation of why God can be understood as three persons in one nature. And we of course know that we have big explanation by means of quantum mechanics how discontinuity at the atomic level can be explained. So in a sense, from the methodological point of view, I would say, maybe I'm wrong, this is sometimes my gut feeling, but I would consider these from the methodological point of view quite close. First consideration I'd like to make is something which it's a very nice text, short but very, I think, very important, of St. Thomas Aquinas, the Aeternitate Mundi, on the eternity of the universe. We all know that atomistic cosmology is based on the Aristotelian Ptolemaic geocentric picture of the universe. And as such, I have to the next slide, I'll return to it in a second. This picture instead does not permit us to introduce the dynamics of the universe. And in some ways, the time coordinate to explain dynamics and the expansion especially cannot be built into the system. It's in some ways internal. This is what St. Thomas Aquinas was struggling with, to show that there is no contradiction between the eternity of the universe and its being created, means being contingent. But Aquinas had a major problem in explaining whether the universe had an origin in time or did not, or it was eternal. And I think part of the reason is that this picture of the universe did not give him a tool to explain a beginning in time. It was static internal, so there was no rational explanation for the origin of the universe in time using such a picture. So the theological truth, which tells us that the creation was time began with creation, does not find a good basis in this conceptual foundation. The next thing I would like to mention, which is very interesting, and what lesson we can gather from quantum mechanics. The reason people started constructing this theory was that we often think that quantum mechanics is a theory which came up sort of from nowhere. Some people just followed it up. It's not really like that, because physics is always driven by a very precise and clear discovery that usually does not find its explanation in the conceptual basis that we have. So we have to look for something new. And really, what was inspiring and what pushed the quantum research forward at the beginning was the discontinuity in the atomic phenomena observed experimentally. And Niels Bohr, one of the founders of quantum mechanics, developed so-called principle of complementarity. This principle was introduced as a methodological principle to try to adjust the classical spatio-temporal description as it fails when we try to apply it to the explanation of the discontinuity in the atomic phenomena. So the principle of complementarity will be telling us, I'll get into this in a moment, that the spatio-temporal description is really not fitting altogether, that it sort of breaks up into certain sections where it cannot be applied together. So, and this finds this final picture in the Heisenberg uncertainty principle. And what happened here, that really quantum mechanics will introduce a new logic for us. We know there's something called quantum logic, in which some of the classical logical laws of inference will change. I'm not going to get into this detail now, it will be too long. But again, we see that with the explanation of some new phenomena, our old conceptual basis based on the classical spatio-temporal description has to be somehow modified in order to be adjusted to explain the new phenomena. As I said, the use of classical natural conceptual basis faces severe difficulties in the description of the atomic phenomena. And we can, this will be a major philosophical jump here, which I will make, just by stating that, just by making the ontological claim that we're talking about something in the reality here. And really, what is conveyed here is that there can be realities in the natural order where our ordinary discourse fails and we need to speak by means of parables. This is a very interesting thing to do, which is when you read conversations between Bohr and Heisenberg, they will talk about really the parable of the wave and parable of the particle, right? Because if we, in quantum mechanics, if we have this major principle of wave-particle duality, and these pictures, both the wave picture and the particle picture of the are complementary in the sense they cannot be applied both. So actually, this description breaks apart and actually is not a description of the so-called real reality, but it's so-called maximum use we can make of our classical concepts to get any hand of the quantum, right? So in this sense, if in theology we approach realities which are, let's say, totally other, then this situation, as much as it was also pointed out by the founders, could be in some ways used as a methodological guidance in the limits of theological explanation. The next example, which I think is very inspiring and very deep, is how physical theory works as we consider the space-time geometry of a spherical star. This is a classical physics, when we solve a problem in which we have the Einstein equation and we want to find the solution of the Einstein's field equations for the spherical symmetric source of curvature in order to obtain the geometry of an empty space around such massive objects as stars, for example, around the sun. So what we effectively do is we have a star like a sun, which is lots of mass at one point, and we want to study a curvature of space-time, empty space-time, which surrounds a star, which would be a sun, could be anything else. And in order to do this, we need to make some further steps, and we, in the first approach, we assume so-called for the space-time, we assume a spherical Schwarzschild metric. I'm not going to get into the details of this, but it tells us, basically the metric tells us how to measure distance in space. And if we use these coordinates that are assigned to the Schwarzschild metric, we see that we end up with something that's Schwarzschild in the corner. We see that we can have two so-called singularities in this metric, which is for two values of r. For r equals 0, so being in the middle of a star, and then for another specific radius, which is called the Schwarzschild radius. And this equation tells us that at these 2 points we should have a singularity. I'll explain what a singularity is in a moment. So that's our situation. We have selected a certain set of coordinates, and in these coordinates we see that we have two singularities for r equals 0, and then for r equal 2gm over c squared. G is a gravitational constant, and is the mass of the black hole, or of the collapsing star, and c is the speed of light, of course. So now, what happens if we get a singular behavior? What does it mean to be singular in a physical theory? This means that some parameter of a theory, for example, such as the metric, becomes indefinite, and for example, the metric goes to infinity. And physicists hate this kind of situation because it means that in that context the theory breaks down, so we cannot have any reasonable description in that area. So what happens here is we need to put the question whether for both values of r, which I had mentioned before, which is for r equals 0 and for rs, are really the metric singular. How to verify this? Because we just use one set of coordinates, and then we ask the question how we verify this. So the best way to verify whether really a given point in a space-time is singular is to change the coordinate system. So we change it to so-called Eddington-Finkelstein coordinates, and in these coordinates we see that the singularity for r equals 0 remains while the rs disappears. So actually the interpretation that physicists would give to it is that because sort of the rs singularity did not survive the change of the coordinates, so it's not a real physical singularity. The only one that could be considered considered a singularity is the one that is independent of the coordinate system. So in a sense, it's independent of some kind of a conceptual basis in which we want to work. And yeah, probably it's time to gather us into some conclusions, because we've said enough so far. And I'll get into some indications for a theological discourse in a moment. What physics tells us, that there are realities, again, I don't like to be pushing this word too much, where access might be difficult or entirely impossible by means of a, let's say, common sense natural language, or even by the classical spatial-temporal language. I mean, these observations were already made by medieval philosophers such as Pseudo-Dionysius really early on. And as we have seen from the example with the explanation of St. Thomas Aquinas and the time of creation, shows us that poor conceptual systems may be blind to extract the entire content of revelation. So if we have a real bad philosophy, that's, I mean, in simple terms, it may be that we don't get out of revelation all that we could be getting. So we can be understanding a little less than we could understand if we work a little bit more. And another, I think, important thing for theology to learn from this is that theology should be aware not to absolutize any kind of philosophy. I mean, today, there's a talk about different philosophies being engaged in the theological discourse. There's a lot being used from the dialogue philosophy, phenomenology, analytical existentialism, whatnot. And of course, there's this, the traditional preconciliar philosophy will be based on Thomism. And I think it's important in theology, based on these things which I said in physics, as we were shifting the different coordinates, not to absolutize any philosophy. We need to be, what is valuable in these different philosophies is that as we move around like the coordinate system, we can be seeing the same truth from a different angle. So we can be seeing different aspects of truth as we change from conceptual one to another conceptual basis, as we did, for example, in the case of these collapsing stars and the space-time of black holes. So as I said, varying a philosophy may enhance understanding of certain truths in theology, or even stress their different aspects. And one thing which sort of occurred to me as I considered this situation with space-time and black hole dynamics is that some of the similarities disappeared as we changed the conceptual basis, and some of the singularities remained. I mean, I may be completely wrong here, but there's a question, maybe there's just a method of trying to see what is really a dogma, what is really a truth which is not dependent upon our conceptual basis, and the dogma could be defined as an invariant of these different conceptual systems. So if we move from one, let's say, conceptual basis to the other, some of the truths will survive, and it means that they have a deeper meaning than just conveyed through our mind, and probably those could be looked upon as truths which we cannot be denied. And also the other thing is that I think theology should be constantly striving to widen its conceptual foundations. The more sort of semantics we have in our head, the more we can understand. So I think it's a very natural thing for theology to constantly look and strive to widen its conceptual foundations. And for the very last picture, I selected a famous saying by Werner Heisenberg, who said that really behind all these different conceptual approaches, the truth always dwells in the depth. And I thank you very much for your attention.